Hello, and welcome to this week's episode of Howdy Partner. I'm excited this week that we have a partner I've been working with for a few months now, Zymbit. And what's awesome about this is that they are an equipment partner. So we haven't had many of them on the show. So today we're actually going to see some equipment demonstrations, which will be fun for our audience and hopefully give you an opportunity to ask some questions of our security experts. And yeah, for those of you who haven't been here before, our Howdy Partner episode or show is a weekly streaming Twitch show where we invite on interesting partners, AWS partners. We talk about their solution. We let them perform some demonstrations, show us how it works, and you as the audience have the opportunity to ask questions and learn as we go and work together. This is a rather informal setting, so we definitely want your participation. But before we get too far into it, I'd like to bring on my co-host for today, Yvan Tamba. So let's welcome him to the stage. Yvan, welcome. Thanks for joining.
I'm doing great, Sam. How about you?
Doing well. And actually, another thing that's really fun is that today I'm actually broadcasting from Austin, Texas. So I'm here with his hometown. So this is an opportunity and a great honor to be
working together for a year, and then we kind of met yesterday for the first time. So
yeah, it's been fun.
Yeah. So hi everyone, my name is Yvan Tamba. I'm a partner solution architect here at AWS. Today we have a special, partner. We're working with them for quite a moment now. Before introducing the partner, before having the partner introduce themselves, I want to give like a deeper feeling to what the sessions are going to be about. So imagine that we want to monitor a patient remotely, right? But the problem with monitoring patient remotely is that we want to be able to take action, very early in the process, right? So what if we have the patient's wearing a device that can collect data and send those data to the cloud? But the problem is we're going to deal with latency because we go to internet. And as we all know, internet is best effort delivery. The other way to go around is to have a direct line connection, right? We might not always have it. So what if we can process the data at edge, right? So that we can alert the medical staff, early in the process so we can take action. Guess what? AWS has a solution for that called AWS IoT Greengrass, which is an edge runtime that allows us, right, to take action ahead of time and process data locally so that we can alert the medical staff, very early. Our partner today, Zymbit, what they do is that they have the devices available to you, but also the build edge, secure edge node, right? So you can have those nodes on top of your device. Not only you can process the device at edge, but also you can ensure, that those data won't be accessed by any hacker through a different hardware product that they offer. Without any further ado, Simon, maybe let's bring our partner today.
Sure, let's do it. Let's welcome our partner Alex and our partner Bob. Here we go. Welcome, both of you.
Hi, Alex. Hi, Bob.
Alex Kaay is the CTO of Zymbit, and Bob Guilfoyle is the director of. Sorry, what is your title again, Bob? I'm drawing a blank here. I know.
That's really director of product engineering.
There we go, director of product engineering. Alex, would you like to go ahead and introduce yourself to all of our audience?
Yes, glad to be here. Good afternoon, evening, morning, whatever it is. Alex Kaay, CTO of Zymbit, also one of the co-founders of the company. We are very excited to be here. AWS has been really just a fantastic relationship for us. We have not only used it, our customers have used it, but also it really fits with our philosophy of how these devices could be used and where we're going with this and the solution that we're providing.
Excellent. And Bob, how about yourself?
Sure. I'm Bob Guilfoyle. I went to school at UCSB and stayed in town here in Santa Barbara. I have a degree in electrical and computer engineering. I spend most of my time working for embedded networking companies and then made the transition over here to Zymbit 3-4 years ago, something like that, and been working here and enjoying this IoT space.
Nice. Well, I've previously heard it, but for our audience, what's Zymbit's history? Can you give us an idea of kind of the origin story? What?
Oh, yeah. That's I was going to talk about that, but let's do that now. That's actually an interesting story. So most of Zymbit's co-founders and some of the people that are still here now and some of the newer ones, we all come from industrial automation, robots, factories, a little bit of military stuff as well in there, aerospace, aircraft, helicopters. So I met my other co-founder, Phil, because we were all in the same space. He was running a robotics company, and I was one of his clients complaining about APIs, basically, left and right. So that's how that happened. That was almost 2 decades ago. And then when we got together and co-founded Zymbit, the interesting thing was that we knew that things could work well. We knew that equipment can run. We knew that this stuff can happen, but it was just so hard. It was so difficult. It was so expensive. And so Zymbit was founded on the premise, let's get to the same level of function. Let's get to the same level of ability and just being able to trust this stuff, but without the expense, without the massive amount of equipment and people and upkeep. So, and then kind of the first bit of that was Zymbit developed its own secure foundation. So that was really the foundation of the entire solution. So Zymbit has become known as sort of the go-to Raspberry Pi ecosystem solutions provider, but we actually aspire to just make things that work. So it's kind of an interesting story with, if you will, a bit of a detour in the beginning, deep into the bowels of security, because we just couldn't find anything and we built it.
Nice. That makes sense. Well, one thing we'd like to pose a question to our audience here, see if we can get a little engagement. Like I said, we're really interested to hear what you have all to think about on the topic. So let me just bring up a question on screen for everybody, and you can give us some of your feedback. So for those of you in the audience, what's your platform of choice? Have you worked with a Pi or a Nook or something else? We'd be interested to hear talk about it, and then then we'll take and see what their take is, get the expert's view. So what are you thinking? Oh, go for it, Alex.
Yeah, I was going to say, whether it's a past, present, or future, if you're thinking about putting stuff up out on the edge, what would you use? Yeah.
Wait a second. Well, while you're thinking and commenting, go ahead and put those in, and we'll respond to them. Also, as I mentioned, as we proceed today, if you have questions for our experts, please drop them in chat. We'll bring them up on screen, get those answered for you. But otherwise, Alex, I'm going to bring up your slide deck so you can kick us off. And if we do get some takers from the audience, then we can bring those up.
Okay. Sounds good.
Yvan, right. Your sound is a little rough, so if you're...
No, it sounds good. Yeah, we can go with our presentation. Why, yeah.
Here we go. Go for it, Alex.
Oh, all right. Very good. There it is. Awesome. So, yeah, welcome to Zymbit, AWS, a demo, and just a general conversation. A bit of context just to start with. So why do we put stuff out at the edge? I think we all kind of know, but the question is a deep one, right? We want devices to be close to people. We want them to be close to the point of use. We want the software running on them to the point of use. So that part is somewhat obvious. How to do that is less so. Zymbit is an IoT longevity platform, as I have already mentioned. We not only want to make things secure or a certain kind of hardware, we would like to have things that run for a long time, and that's really the way to get IoT to have its true value. There are way too many IoT projects that are struggling still to deliver on their value. So Zymbit is all about making affordable, secure, self-reliant IoT machines in general. Another bit of context is that we're talking about Linux Edge IoT devices here. This is ARM CPUs. We're talking about pushing Lambdas onto them through Greengrass, maybe even containers, and all kinds of tasks, and making them to sort of live long and live long. I can't say that here. So just as a general thing, these devices are about as fast as a decently aged laptop. They are quad-core, they're ARM CPUs, 64-bit, about 20 watt of power before you add things to them. quite a bit of RAM. Some of them go up to 8 gigs. Actually, that's our standard config. A vastly variable amount of storage, from 16, 32 gigs eMMCs to large NVMe drives into terabytes. So pretty capable computers, run Linux, decently fast. As implicated in the title, Zymbit's platform of choice is Raspberry Pi. We have been working with Pi since almost the very beginning. Shout out to them if they're here. And we obviously support a couple other platforms for some of the niche applications, but really the presentation today and most of Zymbit's work has been on the Pi Foundation. Why do we like Pi Foundation? It's because we love the developer experience that's in there. So Pi allows us to really have developers that can enter the ecosystem, have a fantastic experience with both hardware and software. As a general note, embedded Linux is hard. Embedded Linux with IoT hardware is harder. Secure embedded Linux with custom hardware in long-term unattended installation is really hard, actually. So we're here to make that hopefully a lot better. And the tools that we have designed are for hard interdisciplinary problems. So hang on one second. Yeah, so many people who are here have seen this. This is the reality of IoT development. We expect something that works out nicely, but we get kind of the thing on the right. The list on the left is too long. Too many parts of projects that don't work out necessarily. There are just a few points. The more interesting, the more salient here is edge compute is not like cloud compute or client compute. It really isn't. Machines are unattended. There's physical attacks that could happen to them. Long operation time. Personnel that maintains them doesn't really necessarily, it's not IT personnel. So it's a whole different environment. And then security then becomes, over a long time, becomes really something that's really hard to predict from day one.
Sorry, yeah. Alex, I kind of have a question here. Kind of like, what is the complexity of kind of, securing edge devices?
Right. So we have a couple of problems here, right? There's a few things. The biggest problem is actually you're securing something that you don't know what's really going to happen in the future. The biggest problem is what's happening now is not what's going to be happening in 2 or 3 years. Some IoT installations, yes, they're pretty stable and there's not that much going on, but a lot of the time business priorities, other things change. And there's new functionality, there's new versions of Linux, somebody wants to add something on there. So really the biggest thing is the unknown. There's this fluidity that's needed. Otherwise, these can turn into kind of boat anchors. And then there's a list of sort of common threats, like people stealing these things, right? Physical attacks, try to take out micro SD cards out of devices or storage. So you have to encrypt that. Certificates and PKI integration is kind of another big side of it. Expired certs can really wreak havoc on an IoT population. And then there's lesser considered things, which more have to do with just the fact that even if everything is secure, just software bugs and well-intentioned developers, right, that just do something that makes these things not work. Yeah, so it's quite a list. I didn't even try to put all of this. It would go for probably another 3 or 4 slides in here. So just quickly moving forward. So
Alex, I've got a couple of questions from the audience.
Yes,
one,
please.
People are excited to see the hardware. So if there's any chance we can just throw that on camera for a second, and we can with their appetite.
We could just go that. Bob, do you want to flip over there? We can just throw that.
I'm sorry. I get it.
No, you need to be on number 2, not on number 3. Oh, there you go. It's coming.
Number 1 is the 3 sends. You want to go to those guys?
Oh, number 1. Sorry. Yes.
that get there?
Nope. There. All right.
Okay. I'm going to go bring this
one
up.
over.
Sorry. All right. So this is the CGI version, and this is the real thing. So here we have, Bob, maybe if you could adjust them a little bit.
Let's get these guys.
You're going the wrong way. Yeah, there we go. So here we have 3 secure edge nodes. These are running as a part of our AWS test cohort. And yeah, so each one of them is a secure edge node. These are based on Compute Module 4. They have Zymbit secure compute module inside.
So here's the.
Yeah, so inside of them is the Zymbit secure compute module that Bob's holding. And then we can switch over to the other camera, maybe, Bob, for the innard. So I'll switch over to you real quick. And then we'll switch over to the other camera.
Did you get that?
There. So this is what's inside a node. So you can see the secure compute module sitting in the middle. Bob, if you can tilt it up a little bit so we can see that it's not just a CM4.
Right.
Yeah. So there's an additional PCB, which is normally encapsulated. This is a debug unit, so it's not encapsulated, but we only sell them encapsulated. And then
here's one of the encapsulated ones.
Yep, that's the encapsulated one. And then below that, we have the motherboard, which is both serves as a dev kit and also serves as the innards of the secure edge node.
Yeah, thanks for bringing that hardware on. We're getting a couple of comments here. Just want to show
Yeah.
our Pi guy.
Let me show you. Can you hear me?
Yes.
Yeah. Let me just flip it over quick too. So you can see we've got
right.
The Edge IO here, USB port, HDMI port, power. It can do PoE or normal 12-volt power, and then some other places for attachment up top, and GPIO header. And then on the bottom side, we've got a header for an auxiliary USB port. These are the blue and yellow wires there are our tamper detect circuitries. These 4 switches out on the corners are also hooked into the tamper detect circuitry, and we'll take a look at that a little bit later.
Oh, Bob, can you scoot a little bit towards the plugs? That way we can see the whole thing. Towards the plugs.
Other way.
Yeah, there we go. Perfect.
There we go.
Yeah, okay.
And then we've got an external battery connector. I have it hooked up to a power source right now that hopefully we can play around with a little bit. But yeah, it'll take a standard 2032 battery on an extender there. And the batteries are used to maintain our real-time clock, to handle any tamper events or other events that happen when the unit's not on. And I think mainly those are the main functions. It doesn't run the unit. It just maintains the usability of all of the tamper events.
Yeah, but there's some really cool things. Yes, a quick.
So we got a related question there. Can you power over PoE?
There we go. Yes, we can do PoE. I don't remember what class off the top of my head, but I believe it's a PoE plus. Physically hardened. So the next question is is a physically hardened version. So there is. So the enclosure that you see, that you just saw, which is this enclosure here, maybe Simon, if you can flip to the PowerPoint quickly, I just have a picture of it in there. So this enclosure here is a hardened enclosure. It does have a perimeter protection. Also, yes, now you could flip to the 3 of them. Then Bob could show a couple of features maybe to the Zymbit feed. Yeah, so Right. So these are not environmentally sealed in the sense that they're not like IP60 something, 6X. But other than environmental sealing, these have intrusion protection. They're passively cooled. So that big light gray thing that you see on there, that's a passive aluminum heatsink right there. And yeah, so these can be deployed in a like a closet environment at a remote site. They also have, and we'll talk about this quite a bit, we have a demo coming up with some of these things. We got multiple sensors in these things, including temperature sensors, accelerometers. So these can detect when they're moved. These can detect when they're frozen for DRAM freeze attacks, for example. Bob, what else have we got on there?
Voltage, low voltage.
All right, low voltage.
Tamper vents, obviously.
Yeah, tamper vents if the unit's opened, but also the units can be configured such that if the secure compute module is removed off the motherboard, then the keys are instantly nuked. And the secure compute module has an internal power source to do that. So there's a lot of layers in here.
Nice. Got a couple other questions. One we kind of slid past earlier. There's a question about supply chain. Let me bring that up for you. So do you run into supply chain issues running these Raspberry Pi platforms? They're sometimes difficult to procure.
Right. Yes. So we have been hit with the Pi supply problems, just like everyone else has, and our ecosystem has been as well. So we're hoping that that's behind us. But yes, we have to get these things ordered a bit in advance as of this moment. But we do assemble them ourselves, and since the supply chain issue has been brought up, these units are assembled here in California. We have very tight control over both the manufacturer of the PCBs and plus our own internal assembly processes. So none of the stuff is made in China. And just as a general note, just kind of the scope of this, these have been out in the field. We are in 3 out of 5 Fortune 5 here in the US, for those of our viewers that are here. We have been pen tested fairly substantially on various products. We'll get to the product line in just a second on the next slide. So these are out there. These are real. You can buy them now. They run pretty well.
Excellent. We've got a couple more questions here. Does Zymbit have quantum key exchanges or any support for Kyber?
Not at the moment. So Zymbit has its own hardware security module. The reason we have developed our own is precisely because things like TPMs, and we'll talk about that after one of the demos, those aren't necessarily perfectly suited for IoT types of problems. So we're obviously looking at these types of protocols. What we find is that also a lot of the times right now, for example, I won't share the names, but some of the really big IoT cloud providers are just getting around, for example, to rolling ECC keys. So a lot of stuff that we see out there, we certainly would love. We would love to have the industry go towards more modern encryption methods and more modern algorithms, but we also have to interoperate. So that's a kind of a bit of a part of the problem for us. We have to, unfortunately, be in step with what's out there. Yeah, we'd love to have those kinds of things.
Thanks. And the questions just keep coming. This is awesome. Great audience. Everybody's getting engaged here.
All right.
Does the RTC automatically update the Pi Linux system clock? How long can it free run without NTP updates? A big problem they have is clock slippage.
Bob, do you want to take that?
You can do it either way. What it does is it syncs up back and forth. So it's best to have an NTP server reachable. That way, if we can set the real-time clock from that, and then with the battery, it's gonna maintain its real-time clock. So yeah, you can do it either way. It will sync the system up. It does like to get the first sync up itself from an NTP service.
Thanks.
Yeah.
So if you put it out in a field somewhere, it's going to maintain time.
Yeah, we have years of battery life without power, And we also, so we use pretty high precision clock components. I don't remember off the top of my head what the actual PPMs are, but we use high precision crystals, and we use better precision parts pretty much all throughout the RTC clock. I know that we can calibrate them if we have a customer that has high sensitivity timekeeping requirements. We actually have GPS clock calibration boxes as part of our manufacturing setup. So we take our clocks pretty seriously. We think that our clocks are probably better than most.
And I think one more question, and we might be caught up here.
That's okay. Questions are awesome.
Can it download crypto keys via AWS Nitro Enclave out of the box?
Bob, do you want to take that one?
I think the answer is no. I haven't looked into that, to be honest, but we don't particularly allow storing keys. We do public keys onto our system. We'll do ECC keys, SEC P256K, Koblitz curve keys, and Edwards curves. And we have some digital wallet type key storage type ideas too. BIP32, BIP39 are supported, and SLIP39. But I don't know if we can actually import those particular keys. We can always protect anything that's on the file system itself. We can lock and unlock it. So
let me say something to this. This is a great question, actually. I didn't realize how great it was when I first heard it or saw it over there. So the way HSMs work, the way our HSM works, is that when there's a key exchange, so we are integrated into the SSL key exchange. We're integrated into pretty much any key exchange that works like SSL. But when the key exchange happens, there's a pair of keys, ECC keys, that's generated inside the hardware. Only half of the key ever leaves the hardware. So only the public side does. So this just has to do with the entire reason why the HSMs exist in these systems. The point of it is to never have private keys, even on the host side, in RAM, anywhere near that. So generally speaking, it's much better to generate the keys on the HSM and then exchange them with whatever that needs to be exchanged, versus pushing the keys down to the device, especially if those are private keys. Now, as for the public keys, Bob, we got PKCS, a whole bunch of different PKCSs, right? I don't even remember which ones we have anymore, but we have PKCS 11. So keys can be stored and they can be locked with the HSM encryption on the disk.
Which that actually is what we do for Greengrass, is we generate a key pair on the, well, first we set up a slot in PKCS 11 store, and then we generate a key pair that is populated there, and then we generate our certificate signing request based on those keys, and off they go. And then when the cert comes back, we'll import the cert back into the PKCS 11 store. And all of that's always protected by the HSM, the keys in the HSM. There's no access to them. And yeah, that's the big benefit of using hardware HSM.
Simon, was there a question about Raspberry Pi 5? We might as well.
Yeah, we have 3 more questions coming up. So the Raspberry Pi 5 question: does a Zymkey 4, is it compatible with Raspberry Pi 5?
The answer is yes. Just give us until January, and there will be an official validated release. Our testing is a bit more in depth than one might expect. Yes, it basically worked, and expect a bookworm update. And then Pi 5 will be supported for sure. Expect that in January.
Just add on to that. Same goes for bookworm support itself. We're waiting to roll it out as we get things solidified with the Pi 5. So that's where it makes the most
sense.
We have echo coming from somewhere.
Yeah.
Let's see. Oh, no more echo. Perfect.
Is that me?
No.
We're okay.
We're good. Right. So yeah.
So coming in early January, sounds like, or early 2024.
Yeah. Coming in January, it basically works, but we're just being cautious. It's not the Pi 5. It's the bookworm support that we want to make sure, because in addition to just the hardware, we also have something called bootware, which is the secure updater for the system to get kernels updated securely. We'll talk about that a bit later on. So that's a bit more OS specific. So yeah. Let me just jump here just a bit more context, because we're kind of answering these questions. So this is the product line, right? This is the product line, which all happens to be AWS qualified devices. So on one end of it, we have the secure edge nodes, which you just saw. The heart of the secure edge node is the secure compute module. And then we have products which are add-on security. So these are pure HSMs on the right. So on the rightmost item is the Zymkey, which sits on the 40-pin header, talks over I2C, and has real-time clock, hardened HSM. The HSM itself is a 2-layer device. So there is a secure CPU, and then there's, in addition to that, there is a hardened secure element with grids and so on and so forth. So that's the add-on. And as we go from right to left for some reason here, as we go from right to left, we got the secure compute module. So the secure compute module is the CM4, Pi CM4, which is bound together, literally glued and epoxied with the Zymbit PCB that's in the back. And then the Zymbit PCB is not just an HSM. It's a full system supervisor. So it's a lot more than an HSM. Full system supervisor conceptually is sort of like the BMC on like a server, a proper board management controller that can control the CPU boot process. It doesn't have its own access to the internet, but or to Ethernet. But what it does do is it can inspect the contents of the disk before booting the CM4. So that gives us the opportunity to do a lot of really cool things with this, such as, for example, to exactly know what's going to boot, but also being able to fix some of the boot problems that could happen. So that's the secure compute module, and then that sits inside the secure edge node, as we saw earlier on.
Question coming in about the SCM. For the encryption module using I2C like ZK4, or does it have more bandwidth?
Great question. It does have more. It is a USB-based module. So so it's a bit more capable. HSMs are not really crypto accelerators, right? So it's not something yet that you'd be running your your AES block cipher through. Pi 5, speaking of which, since we broached that subject, Pi 5 has a much better encryption bandwidth, 43 or 38. Bob, do you remember? It's a big number.
I don't know offhand.
It's a big number. So so these are not crypto accelerators, but yes, SCMs have quite a bit more bandwidth and capability than the I2C Zymkeys. Any other questions we got to address? Or we'll roll forward.
We have a couple others we had to skip over here earlier, but you can continue so you can move forward, and then we can kind of fit them in where they make sense.
Okay, perfect, great. All right. Yes, a poll question to get conversations going, and this is I would be really interested to know lifetime of devices, projected, maybe actual, but at least projected. What's the design lifetime? Or what's the business requirement? This is I would be really curious to see.
So for those of you in the audience that are currently using edge devices, what's the expected life? What have you seen? What are you hoping to see? If nobody in the audience is currently using devices, what are you planning for as you go to deploy them?
Yep.
I guess while we're waiting on that, there was one follow-up question. Does it use a TPM module?
The answer is no. We don't use TPM modules because TPM modules do not, in short, TPM modules do not have two things that we especially need, many reasons why they don't work. One of them is that they don't have instant key wiping, and they don't have the low power ability to do so off a very small energy source. We need that, especially for unattended devices or that are sitting without power for a long time. So we can do that. That's number one. Number two is just more of a generic thing. TPMs are made for computers or servers, and it's just kind of the wrong fit of sorts. It's a deep question. We actually have a slide on that, but why don't we defer that until after we talk about Zymkey later on in this presentation?
Sounds good. And I saw there that our Pi guy mentioned that she has a 10-year target for their devices. So how does that fit in with what you're expecting?
Right. Yeah, that's our design target's 15 years. That's what we're aiming at. We know that not every customer is aiming at that, but 10 years is I'm trying to estimate how many majorly new Linux kernels that's going to be.
Well, it's every 2 years, so.
Right. So that's 5 or 6 big kernel updates along the way. So that's why we have bootware. That's why we have secure, and that's why we have secure updates with ADs and fallback. We'll talk about it in a bit. All right. Any other questions, or shall we jump into move into our, well, actually, let me do just one more intro thing, because there's a lot of questions about lifetimes and applications and what is that. Here's 2 applications that we see as being really great examples for us, and maybe that will also spur some more questions, which is fantastic. Retail store automation. This is not really about automating humans out of stores. It's about augmenting humans. So it's a big man-machine interface problem, as far as I'm concerned. Speaking like an old industrial automation guy here, and the nodes get placed just about anywhere. There's no control oftentimes over the network environment. Sometimes there is, sometimes there isn't. What makes this really interesting is that in addition to being mission critical and just having to run all the time, these devices contain customer data, not all the time, but oftentimes. But they also contain trade secrets, which is recipes, equipment, profiles, and all kinds of things. So within these contexts, a single device compromise is really something that's frowned upon. And so the answer to these types of environments is a layered security and resilience framework, which is what we do here. So we have layers. Physical security is one layer. Our own secure boot infrastructure is another layer, and so on and so forth. These devices aren't really maintained by especially qualified personnel. So yeah, so that's the kind of thing. And so secure edge nodes really seem to be working out really well there. Another one, I think it's obvious just by the somewhat awful picture we have here on the right. I apologize for that. Edge AI is another one of these applications where the model gets pushed to the edge. We obviously want to make sure that that doesn't get accessed, and also extremely frequent updates for the edge AI devices, both OS level, model level, payload level, all of the above. Things change very quickly. Any other questions?
Yeah, a couple of questions just came in. Do these devices support Spire agent or somehow compatible with Spire?
No, not at the moment, but we can have a conversation if you have an interesting application.
Fair enough. Or it's like, wrong one, jumped around here. Or Spiff also?
Yeah, we could have a conversation. We're interested always in various kinds of infrastructure. So yeah. But at the moment, no.
Excellent, thanks.
Oh, also just a kind of a quick note. If you can make things run on a Raspberry Pi with a soft HSM, Zymbit's HSM API is very similar to soft HSM. So if any of the stuff, I don't know off the top of my head what it uses under the hood, but if it runs with soft HSM, it would not be very hard to make it run with the Zymbit infrastructure. On the OS side, because I'm anticipating some of the questions, what are the OSs that this will run? Why? So OS is generally speaking, again, things that look like Raspbian run with our infrastructure very well. Things that might require a bit more work are things that heavily use the Snap system. We're working on Snap support, but we're not there yet. So there are some of the more exotic system layouts that we could that we could support in the future. Oh, great. Okay, so it could run the Spire agent then. Great.
Another question I think you're going to be touching on during the demonstration. How do you manage securely vending certificates to these edge devices? Do you primarily deal with more private devices or devices where end users can get issued certs on the fly?
Yeah, so great question. This is a problem that has come up a bunch of times. So we have, generally speaking, two answers, and both of them are a bit longer conversation. We have a mechanism that is based on the code that's inside the HSM that can provide securely updates to devices based on forward knowledge. This is something that we have upcoming, and our enterprise customers have some of that technology. So that's kind of that part of it. And I'll just leave it at that, and it would be happy to have a discussion with anyone who needs that. The other option is that we are working to have an HSM-based certificate authority. So that's also upcoming. So as of right now, again, this is a thorny problem, because the other problem that this is related to is spares. So hot spares, for example, if you have a deployment of a bunch of, let's say, a couple of thousand devices, even a relatively low number in a population, you might want to make 100 devices and put them in a warehouse somewhere, so that if someone needs one, it can be put in a box with a FedEx label and shipped to wherever it needs to go, and then rapidly provisioned. Well, if you have a bootstrap cert, and that cert has a 30-day expiration or even a 1-year expiration, it's not going to help you, because it's going to probably expire if that thing sits there for 5 years. So yeah, so that's we're very aware of these things, and we have solutions that are coming out in a pretty near future. So reach out to us if you have an immediate problem, because we have various add-ons that are possible. All right, how are we doing on question?
I think we're basically caught up.
Okay, so let's see. We talked about applications. Oh, yes. For those of you that are here today, you could get a free Zymkey. I forgot about that. That's very important. So follow the QR code wherever it takes you, hopefully to the right place, and we will ship you one.
Awesome. Just for our viewers, I'd like to clarify that this is not an AWS giveaway, but it is very generous that they're offering it, and we're happy to have you here. So say check them out.
Awesome. Thank you. All right. Simon, without further ado.
Demo time. That's what we've been waiting for.
Right. So I'll just preface a little bit, and then I'll hand it over to Bob. So we have a demo of getting AWS Greengrass working with Zymbit HSM. So there's some interesting differences with how that works versus standard examples. Because the process of getting AWS Greengrass set up is a fairly lengthy process, we are not going to go through every step here. So we will post a, let's say within the next few weeks, given it's holidays, We're going to post a more concise demo, really step by step. But what we'll cover today, more importantly than just a dry demo, step by step kind of thing, is what's different and why it is different, and what are the little gears that are inserted in a standard AWS Greengrass setup. So that's kind of going to be the focus now. But we do have a guide up on the website. I don't know if there's a way to post a link, but we have a guide on the website, which is a step-by-step guide on how to get this going. So Bob will be loosely following that. Anyway, over to you, Bob. We have.
Yep.
Real quick before we move over to.
I'm going to go ahead and re-power cycle this.
Simon, we have a few slides, so Bob will be talking to a few more slides. So why don't you leave the slides up for now, and then once we're ready to switch over to Bob's cameras and to the screen feed, we'll just do that then.
Sure. And this is a good time. We're about halfway into the show today, so maybe I'll let Yvan step in and reintroduce the show and reintroduce our guest today.
Okay. Hi, everyone. Thank you if you're just joining us right now. Today we have Zymbit. They are proposing or showing us the different, hardware solution that they have for customer, mostly edge node devices, how to secure your devices, how to secure your edge node devices, leveraging the different products that they have. They have the security hardware module that you can incorporate Raspberry Pi as well. So now we're heading into the demo. They're going to show us how their device can, integrate with AWS IoT Greengrass and how you can leverage that as well in your environment.
Thanks, Yvan.
Yeah, so Bob, you can, it's up to you.
Okay. So this basically, I'm going to power cycle this guy while we're talking through what we're going to do or what'll happen today. So you can see this. I don't know if you can see the.
We're not on that feed yet. If you want to flip it over right now, I have the slide up in terms of what we'll cover.
Okay, that's fine. It's just going through its boot cycle, so I can describe it to you. It's
Why don't you flip over to the overhead camera on that before we start?
Sure.
So that you're on the right feed. And then I'll flip it over to over here. And then scoot it a little bit towards the plugs again. The plugs, I guess, push it off the. Yeah, perfect. Okay. Great.
So, so it's the secure compute modules. SCNs take a little bit of time. Edge nodes take a little bit of time to boot up. What they do as they're booting up, and they run through a sequence of flashing blue LED codes. They basically are securing the boot chain. So we pull all of the boot artifacts down onto our unit. Anything that you want signed, anything you want signed and verified, and then we check and make sure all of those artifacts verify before we allow the Pi itself to boot up, or the CM4 to boot up, or the SCM to boot up. So that process takes a little bit of time. You can see if it's getting through that. It looks like it's still working on it. It takes like about a minute or two to complete the boot up cycle. So then as it gets past that cycle, the next flashing will be a little faster. As it starts to boot everything, then it will go quiet to when it's getting ready to do its USB discovery. And once it's done that, then it'll go ahead and boot up like a normal Pi, and you've got the wonderful Pi development environment for you, all your Linux right there.
Just it's a little bit hard to see on the video because it's pointing the wrong way. But right next to the barrel jack, Bob, maybe you could
it's
point
almost,
at that. There's a blue LED right next to it that's blinking.
There it is. Everyone see it?
Can you see it at all?
Yeah.
Okay.
There it is. It's coming through now. So, so the important note is that blue LED is not controlled by the Pi. That blue LED is controlled by the HSM itself. So that's a secure CPU that blinks that to indicate that everything is secure and running properly.
Right. So that's also blinking on the on the SCM itself. Those two are synced up through our motherboard.
Yeah.
The other thing to note here is once it's blinking once every 3 times, then that signals that the the SCM is up and happy and everything's running. So we're good. These, do I need to share this screen or?
Yeah. Would you like me to go to the screen, Bob?
You can go to the screen.
Okay, there we go.
The SCMs, as we ship them, as they come out of the factory, come with pre-installed Bullseye 64 right now. Probably be considering Bookworm possibly when it's time to do that. Most of our customers, bigger customers, are slow moving also. They'll probably stick with Bullseye for a while. We always support the long-term stable models. The other thing that as it ships, we also preload all of the Zymbit software. So it's all ready to go for you. And all you have to do is power it on. And for access, we limit it a little bit. You probably would want to do standard normal Linux practices on your own for securing access to the box. We do set a host name common through all the products as they go out. So you want to change that, change your logins, secure them with keys. We restrict console access. Most of our customers run headless. So use SSH only when you get as it comes out of the box.
Yeah, this is what the console typically looks like. Just if you connect to the console,
yep,
that's what you get.
You get a splash screen and you can't do anything.
Yep.
Again, a good security practice would be to go through standard Linux, Raspberry Pi type activities to close it down for your situation. What else? We encrypt it. So as it ships out, the root file system is encrypted. Let me see if this is. This one is not. This one's a fresh unit. I can look at it. I can show you another one in a minute. Actually, I can show you right now, I think. Let's see if I can get to another one. Okay, so these guys, this is more of a production unit. You can see there that the root file system is encrypted. This particular unit has bootware on it also. So there's another partition here, 3. We might be able to show a failover to that. It's also encrypted. It's a mirror copy of, or recovery copy of A. And they're both encrypted separately, separate keys. No way to get to the other one from the one you're booted on. So we'll talk about a little bit more about bootware later, but we're working on some things there to give you good safe A/B updates. But any unit we ship out of here is encrypted when it goes out the door. Okay, so let me. You want to go?
Do you want to switch back to the
yeah,
slide?
let's go through the slides quick and just
yeah.
I think we covered most of the overview of what we're doing. So let's run through the next 2 maybe.
Yeah, okay. Next one?
Yeah, and we'll come back to this one then.
Oh, this is just a quick specs. Let me just cover that. Let's just flash that up so that I'm sure that not every user of ours is especially familiar with the Pi Compute Module 4 base system. So this is just what you'd expect here. It's a Broadcom quad-core CPU, 8 gigs of DDR4, 32 gig eMMC. There is a M.2 slot, so you can put another drive in there. Wireless, as you'd expect. Bluetooth, usual Pi GPIO, HDMI 2.0 ports. They're nominally 4K P60. I wouldn't recommend it on both ports. It really bogs down the machine, but you could for static displays. You've got some DSIs. You've got the PCIe, which goes into the M2, and 1 USB port. We also have 2 USB port options. You also get an internal port, so you got a bunch of USB ports. I presume no major questions so far, but if we got them, we could stop here, and then Bob's going to jump into the green grass, how that works, and how we do it with the HSM and with the Zymbit framework.
I don't think we're waiting on any questions. We've had some comments inside, but I think you can go ahead and continue.
Okay,
great.
This is the picture straight off the Greengrass site and AWS's Greengrass site. It's just an overview that shows what what was explained earlier is that you've got these edge devices out there. They're out in the wild. Sometimes there's latency or no connectivity at all. They can communicate back to the green gas core devices, which then can communicate back up to the AWS cloud. So you have this full environment that's like ideally suited for things that are out in the wild, drones and tractors and whatever else is out there. Retail applications. We can go to the next one. Okay, so this is basically, we did talk a little bit about this earlier, but this is basically, and this is again from AWS and a nice blog post, that this was for, I believe, for soft HSM, but we follow the exact same model. In fact, we discovered today one of our little print statements says HSM, soft HSM still, but it's the same model. We've copied and elaborated on the soft HSM model. We added basically 2 commands that can allow you to init a slot with using our Zymkey libraries, shared object libraries, and specify, I believe it's first 3 slots at least. I'm not sure if on the SCM you could do all the available slots, but at least 3 different key slots are available for you to use. Those let you set up the token slot in PKCS11. And then there's another additional command. Again, the syntax is very similar to soft HSM util. And that will allow you to generate the key pair and put the keys into the PKCS11 area. We also, along with just using our keys, we have the ability to bring in keys from the outside. So since we don't do RSA ourselves in our products, you can actually create an RSA key, 2K RSA key, and then put it into the PKCS store, and it will be protected by the private key. So we basically lock another layer on top of the already kind of hard to get at PKCS area. So we can do the ECC keys, and we can also import keys, RSA keys. Okay.
Great. Next slide. Oh, yeah.
Yes.
You could get it now.
It's
there.
Operators are standing by.
The operators standing by, right. Right, yes. And other things. Okay. Let's go straight to here.
Yeah. Okay. So what we're gonna do here, the first step, basically, and this again, we're following for the purpose of this, we're doing the manual. We're going to do the manual provisioning installation because it's really the kind of the pertinent part. Because what we bring to the picture is the getting the keys into getting access to the HSM. So that's what we're going to focus on, and then we'll follow up with a more entertaining full green grass setup some time in the future. So what we're going to do today is basically first thing is power it up, which we did. Everything's installed and ready to go. We can wait till 3 seconds are blinking. You need an AWS account. You need your credentials to get in, and then we'll go ahead and start to get into creating an AWS greengrass thing, and then bootstrapping that thing. So let me log over there. We're there.
All right.
Perfect. I got a quick question, just as you said up there. Just said this comes with the CM4. I think that was in reference to the last slide you had up.
Yeah, the SCM has a CM4 on it. It's sandwiched together so that you get CM4 on top.
Let me flip over.
Yeah.
No. Just stay there.
Yep.
And then put it under the camera. Yeah.
So you got CM4 on top, Zymbit smarts on the bottom, and then it's all sandwiched together and epoxied together. So there's no easy physical access to the unit.
Yeah,
to the module.
And it knows when it's been taken off its motherboard. So if that happens, and if it's properly armed, then
Yes.
It's basically gonna self-destruct. I mean, not physically, but it's not going to be reusable after that. If the key destruction is armed and it's triggered, then it's a very nice paperweight.
Basically got fingers on the back here and a flexible PC connector for another way to get to the tamper events, tamper detect, or create your tamper loops. They do transfer down through. I don't have an open dev board, but there's fingers on the bottom here that are picking these guys up, and then the battery connections here, and then your standard connections up to the CM.
Yeah, and that's a Rev A. So we could we get a Rev B, which are the current shipping ones also, and then Rev Bs have an additional 40-pin connector for extra board integration. If there are questions about hardware integration, we'd be happy to take them. We could get through this first, and then if there's time, we could cover a lot of hardware integration.
Sure, go for it.
Yeah.
All right, so let's get back onto this.
Okay, so I'm gonna focus on basically this is all in our getting started guide. The getting started guide is accessible either through the AWS Qualified Partners products page, catalog page, or from our Zymbit site itself, docs.zymbit.com. What I tried to do here is consolidate the different steps into a couple of scripts quick. And I'm going to try and highlight, let's see if I can get to. The first step of all this stuff was just getting all the packages installed that you need. You need Java, you need the AWS CLI, you need to configure your AWS CLI based on your endpoint, and then it's describing your endpoints will make sure you've made it there, and then you can get on to creating your IoT thing. So this is all standard stuff that happens for any kind of IoT device when you're adding a thing. So I'm going to run. I think I ran that already to save us the fun terminal viewing of Java getting installed. The next thing we do is pretty much the heart of what we do, and these are some Bootstrap scripts that we reference in our. Where are they? Oh, there.
I think it's a step, yeah.
And these go through the process of actually creating doing the Zymbit functionality to get the keys set up and get PKCS11 and get the keys set up and then pushed into the PK7. Let me see if I can get this up here. Might be able to see this a little better. These two commands right here are the heart of it. So this first one, and if you know soft HSM, this is going to look very similar. But instead of
just a quick thing, Bob.
Yeah.
Maybe just a super short refresh of what PKCS11 is, if those in the audience aren't familiar.
Yeah, it's a PKI key store, so it's a safe area that everybody uses it or has been using it. So it's very well known, very, very common interface. I don't know if there's anything you want to add or.
Well, so that's integrated with the HSM. So now this is not your just a disk only.
Correct.
PKCS11. So that's the key point.
Yeah, you no longer need any private keys or the cert for that matter if you really want to. For AWS's case, I think you need the cert to be in there now alongside it in the same slot. But yeah, no private keys sitting on your file system and memory anywhere that can get accessed. So these are the two main things that we do, and then the other big part is just accessing those keys and getting your your configuration set up so that you can relay those keys up. So let's walk through this a little bit here and see if there's anything else that. So we're installing some of the other packages that are needed, double checking them here. But this script, by the way, was mostly done by AWS, the team. We did modify it a little bit recently when we went through the qualification process. But we reference the original GitHub entry up there. So basically, this is going to take us through getting a key, generating a CSR, and then going and getting it signed. So I'm going to run this.
Right, and this is getting signed by.
This is getting signed by the root CA.
Well,
signed by our key first. Yeah.
It's signed by our key, and then it's signed by the AWS.
Yeah, you can. We're signing it with AWS's or Amazon's root CA. You can also bring your own. So it's either way. We're gonna use the Amazon key today. Okay, so I'm gonna run this, and it's live. So hopefully this works. So we can see this here. It doesn't take too long. It's going to do some package checking. And then it will go on, create that store. I should have taken a look at showed you that there was nothing in the PKCS11 store first, but good time for questions. If there's any other questions coming by.
Not seeing any recent questions.
Okay.
People have their fingers are crossed. They're praying to the demo gods, so they're on your side.
Oh yeah.
I'm honestly about 50-50, but hopefully we're good.
But yeah, if anyone had a question earlier that I have missed, feel free to drop it back in and we can discuss it.
Yeah, just a general comment while that is doing its thing. We're generally trying to stick as much as possible to the various infrastructures. So soft HSM, as Bob has mentioned, that's what we've modeled and kind of elaborated on for our infrastructure. We are trying to keep everything as common as we can. In fact, I just remember there was a question about the Pi 5. Apparently, we have a customer that is already running our stuff on the Pi 5. We just didn't know about it.
They're running Bookworm.
Right.
Sorry, I thought I'd done. Thought I'd updated all this stuff ahead of time here. It looks like it found.
Well, it's
found new stuff.
We have to start with a clean system. Otherwise, you end up like in the middle of this thing without like not knowing what's updated, what's not. So it's going to get there. Bob, anything else that we can elaborate right now in terms of just the process of this Zymbit and Zymkeys?
Yeah.
Differences between Zymkeys and SCMs.
Exactly. Yeah. As far as this is concerned, they're both the same. So as far as the connections for your basic PKCS support, they both work the same way. The SCM has quite a bit more physical protection. It has the Zymkey has basically tamper detect ability. The SCM has, let me see if I got a slide here that I could look at while we're doing this. So these are all the destructive actions that.
A great slide.
You like that?
Yeah.
That you can actually set up and take. And we have two modes on these things. One is development mode, the way we ship, where you can't really destroy things, pull the rug out from underneath you. And with the SCM, it flashes some sequences so that you can see you've hit some of these events, and then it will recover. So, but you would need to recover. So if you create a tamper event, you're checking out your code, you want to see what happens, you set it to self-destruct. in development mode, it's only going to flash a code at you 3 times, and then it's going to reset. If the tamper event's still there, it's just going to keep doing that. So once you close that that perimeter event back, or perimeter loop back up, then you're good to go. No boot back up, and then you can change the things. All of these things, pretty much once you've gone into production mode, you can't change the settings. So with tamper in particular, you get one shot after you put it into production mode to change it. Otherwise, somebody could come in after you and just say, I don't need that anymore. So one chance to there, low temperature thresholds, it just won't boot when it's in production mode. Same with either of the temperature modes. I don't think we're going to show both of those. We might be able to.
Well, and just to mention an important event detail, tamper events do run even when the device is off. So as long as there's a battery which has been correctly installed inside a device, all of that will run for quite some time. I'm saying quite some time because it depends on how big of a battery you put in, but 2032 battery runs for a good number of months, if not a year, depending on temperature, ambient conditions, quality of the battery, and so on and so forth.
Okay, so this finished. So it went through here, loaded everything, then it fixed up some user accounts, it found our library, and then it used that to run. So this is just listing out the objects that were in there. So it's doing that. It gets the greengrass modules. It's actually determining the slot number that got chosen when we initialized the token. Here, that's then fed into the spot where you're actually going to load the key, or generate the key. And then that is used here in OpenSSL to generate your certificate signing request. It's going to go in and grab the key from PKCS11. It's using our Zymkey engine, OpenSSL engine, and then it's going to generate out this Zymbit CSR. Then that CSR will get sent up to, I guess we don't print it out here, but it gets sent up, and a cert gets returned from sent up and with the root, works with the root CA to send back a cert to us. So the end result of this is that we should have a cert here. Yeah, we do. Okay. And then we also have a reference for the ARNs here if you need to use it. I think they the original Greengrass folks at AWS have a Greengrass revisioner that takes care of a lot of this stuff. I wanted to walk through a little more of the actual manual stuff so you can see the parts that are pertinent to our HSM interface. So let's see now if I've got a couple commands here, we can go look at things. So that's going to write the cert in, which we can also automate, but we're going to leave it for now. So if we go look at the actual Zymbit's view of the PKCS, and of course that didn't work. Let's try that again. So in here, when you first open this up, there'll be one slot, and then we come in and initialize a new slot, and Soft HSM or PKCS11 will always give you a new slot for the next one. We created this one, and the slot number is 533612. So that's the slot number that we're going to need to reference. I'm going to just stash it here for a minute because we'll have to use it later. Oh, that's cut and paste is working pretty good between my monitors here. Let's try that one more time. Otherwise, I'll just have to get it later. Okay. So this is showing us that we now have this slot in there. The label is greengrass. And so that's where things are going to go. And then that second command here is going to populated with a private key. So let me see if I can get the, if we use the PKCS11 tool now, I think I need to be sudo for that. Okay, so in here we can see now that we have a private key and the public keys in here too. I don't think you need that in there, but private key and public key are now stored in your PKCS11 store. This number here is the hex version of this number here. Yeah, that's displayed that way there. So that's what that is. So that's the slot we're in. And then what we want to do, we're going to go ahead and for the AWS things, the certificate and the slot, or certificate and private key, need to be in the same slot. So we'll go ahead and use the tool here to put that certificate into the slot. So where did I lose my screen? Here. Okay. And once again, I won't copy and paste. Let's try it one more time. Okay. So this should give us a, this is going to put in the, oops, I got something wrong there. What do I got? Label IoT key type cert slot number. So I need this actual slot number from above. Okay. And now we put the cert in there. So now we can see that hopefully now we have the public key, the private key, and the cert, and they're all in the same thing. Now I noticed this is probably not going to work because
you put it in the wrong.
Yeah, these guys had zeros in the bootstrap script, so it won't work. But I'm going to go through the whole thing anyway and show you what the rest of the process.
And you also have them under different labels because one's Greengrass, the other one IoT.
Yeah, so I grabbed an old bootstrap script, so I apologize, but we have another one we can look at that is ready to go. Okay, so the next thing we'll do. Oh, I can go over here and look now too. So over in my IoT core devices, now we should have a thing here this is Zymbit dev. So it's there. I don't think we've associated with a certificate with it yet. No, so there's no cert. So that's the next step here, is to go ahead and associate the, let's see, that's step 2, right? So in here, we're going to provide the ARN for that, for the cert. And we're going to go ahead and attach our thing to the cert, and then attach some policies and create the roles and get everything almost ready to go. So, and then we'll pull down the root CA and add some fix some user things, install Greengrass stuff, and we're pretty much ready to go. So like I said, we'll monitor the progress. I don't think that the scripts were set up completely right. Okay, so the ARN would be the ARN that was pumped out from the bootstrap script. That should match our certificate.
Serial
here.
number, yeah.
So if we look at the certificates, they're not, let's see, security certificates. And what did it look like there? This is ends in, it starts with 050035. 050035, that's one we created now at 320. Okay, so the cert's up there now, so we're just going to tie the two devices together by putting in that ARN. And go. How's it going? Okay. This doesn't take too long either. So it's attaching policies. No, it's missing a policy. I grabbed the wrong script, but that's all right. We can see the process, and then I can show you the results.
Do we have any questions on any of this?
I'm not seeing any questions. I have a question for you, though. When you brought up the destruction actions earlier, it made me interested, especially the temperatures. What is a threat vector that we're addressing by monitoring low temperature or high temperature? What are we protecting?
Oh, well, on the low temperature, the threat vector is DRAM freezing.
Okay.
So if you cool the device far down enough, then you could power it down, and and DRAM will be essentially fully preserved. Then you probe the DRAM chip, and you get the data out of DRAM. And if you have keys in there, then all the keys are yours. You can scan for keys. There are tools to scan for keys. High temperature is just sort of, if we have a low temperature, why we might as well have the have the high temperature. Sometimes that's just dealing with abnormal operating conditions, and sometimes that's dealing with some forms of power supply attacks and so on and so forth, differential power attacks. You could get into that, but high temperature is more of just a counterpart to the low temperature.
Okay, yeah, that's cool. Thanks.
But low temperature, actually, DRAM freeze attacks work surprisingly well because DRAM just keeps the data.
Okay. All right, so this is completed now. And then if we go back over here to our thing now, let me go back to the Zymbit dev, one we created tonight, or to the say. And now we have a certificate underneath it. And it's the same certificate we looked at earlier, the CN Zymbit dev. This ARN matches our earlier ARN, and we're good to go. So theoretically, that should all be it. Now I know I messed up the slot IDs on those things, so with my scripts. So we can't quite do that, but I can show you the next step of what you do is basically now what you do is you go in and edit this config.yaml file, and I'll show you what that looks like. Let me copy it over to Greengrass.
Yeah, we don't need to go through all the steps, Bob, but let's cover the basics so that we have time left for the Zymkey demo.
Yeah. Okay. So in here, what you would do is match up your IoT key or your IoT device key. I think it was Greengrass for this one actually, but normally I'm a little more thorough, but not today. And then you need your thing name here, which would be, this one was Zymkey dev, right? Or Zymbit dev.
Yeah.
And then you need your root CA. You need the right one.
As we discovered earlier.
Yes. The root CA key that this was used by default is the RSA key, which is CA1. CA3 is the ECC key, which we've used when we do things by hand. Then you need the IoT role alias, which I think since that was wrong is probably not correct either. So, and then the endpoints of your region and where you're at, and then you need, this is the important part here. So down in here, you need, the name is fine. Any name works, I think. The library is important because that's what's going to be referencing our implementation, and the slot ID. The slot ID has to be correct. So
yeah, just a quick note. So just because I suspect some people are wondering how does this really work. The way this works is that Zymbit has a library Zymbit runs a daemon, and then that daemon talks to the HSM or the SCM, the supervisor CPU, via either USB or I2C, depending on which product you got. So the requests go from the library to the daemon, get then exchanged back and forth as needed with the HSM, and then that's what you get back. So that's what happens under the hood when that runs.
Okay, so normally, and in the interest of time, we'll just do this, but normally it would be this, you would put in the big number that comes back from when you initialize the token. I got zeros in there for some reason with my script. So that would be all you need to do. And then you can go ahead and start your Greengrass install. And that will bring up it'll go ahead and it can use your configuration you've got in there. It uses the PK CS11 package that you need to load also, the trusted plugin. And then away you go. So that's about all you need to do. So I'm going to run it and it's going to fail. And then we can go back maybe in a minute as we go through the slides. I'll swap in one that worked and we can see that it actually connects up. So let's just do this. What is that? Step 3, right? Okay. This just takes a little second too. Okay, it's done. It's checking the, gonna check the Greengrass service, see if it's installed. This guy says he's happy. This sometimes will happen because soft HSM is around, but it doesn't matter. And then if we look at the log files in here, we're gonna see errors. Let's see. Greengrass.log. Okay, so let's see if we can see.
Hasn't gotten far enough, maybe.
It started. It says it's running. I think it's going to fail eventually because it has different. I think that ID of 00 and the big number aren't going to match. But that's basically it. And then you're good to go. And then you can set up your deployments. Greengrass version 2. I think most of that work usually you do on a device out there, set everything up, build your component the way you want, and there's some really good examples out there.
Awesome.
And then you set up your deployments to go grab it from an S3 bucket, and then you can send it out to the world of devices.
Yep.
So that's basically the overview of how that works.
Thank you, Bob.
Yeah, let's send it back to you, and I'll swap this quick, and we can take a look.
Yeah, Bob, thanks for the demo.
Right, great. All right, so we will follow up with a bit more information, and I don't know how we could follow up with some of the people that are watching us now, but we will be posting a more concise, a better organized demo with all the details, and there you'll see these devices responding to the various events. We have devices that do respond to events here, but we have another demo to jump into. So why don't we do that? Unless there are questions on
that topic, real quick, Alex, I'm going to go ahead and share your contact information and Bob's contact information. So if they do have questions about these demos, they can connect with you on LinkedIn and hopefully get some more answers.
Awesome. Okay. Great. Absolutely. We'll be glad to. So why don't we flip over to the presentation real quick? I will cover some basic Zymkey overview while Bob is switching over to the Zymkey.
Sounds good. I'm hearing a little bit of feedback, I think, from yours again, Alex.
I'm not sure. Yvan, maybe try muting. Let's see. Is that better?
Sounding good right now. Yep.
Okay. I think that's where it's coming from. All right. So on to the next demo. In the interest of time, I'm just going to do it all on one slide pretty quickly here. So the reason this demo, I find this really cool is because this is an instant add-on to any decently modern Raspberry Pi. There's a Pi 4 Model B. Well, obviously, it'll work on other Pis and other 5 and so on and so forth. the Zymkey is this little thing in the top left corner that just plugs right in. And what we're going to walk through is enabling that, and then basically how to secure a Pi. If you've got a Pi that doesn't have anything, we highly recommend you do it, because among other things, it will encrypt your micro SD card, so no one can take that home. And it will also then allow you to obviously not have keys in the file system. So even if it's encrypted, it's still not protected from the inside necessarily. A part of Zymbit's threat model is different levels of trust depending on what part of software is running. So we trust secure boot and supervised boot and bootloaders, and then we trust the secure enclave that we have for bootware. Then the system boots into initramfs, and we trust it a little bit less. We give it less credentials, but we trust it more than the user code. So that's all a part of the layered system, and so therefore in kind of real world, it's actually quite important to not have keys hanging around in the system that shouldn't be hanging around there. So that allows you to clean all that up and encrypt the file system as well. Bob, are we ready for the next one?
Yeah, we can do that.
All right, let me flip over here.
So if you have want that camera real quick, and I'll just show how this goes on.
Let me flip to the camera, and then Simon, we can flip to the, maybe scoot the other one out of the view a little bit. Perfect. All right.
Okay, so this is a Raspberry Pi 4. This is a Zymkey on here. It's got a few other things on it. It's got a spot for a battery, which this one has a battery in it. And it also has an auxiliary thing that allows you to hook up to tamper detect. So I've got perimeter 1 hooked up on this tamper detect. It plugs into the end on a micro USB connector that's available from our site. So if you just pop that guy on there on the first 10 pins of your GPIO header, we'll power that up. It starts flashing as it comes up. We basically use the I2C bus and GPIO4 and then power and ground, and that's it.
Bob, is there anything to see on the console if you want to flip over to the...
I'll flip over there now, yeah.
To the third feed, and then...
On the third feed to which console?
Oh, to the Pi's console?
I don't have the... Well, I don't think there's anything to see. This is just Pi. This is Raspberry Lite, okay. So there's just a...
It's headless?
There's a login prompt.
Oh, okay. That's all there is. All right, that's fine then. We'll just log in. So I'll go over to your terminal now.
You
right?
go over to my terminal.
Okay.
Okay. So I think I haven't installed anything here yet. So we're going to run through and install here. So before you install our software, you're going to see the Zymkey rapid flashing like that. And there's two things you need to do. Well, there's one thing. You need to enable I2C bus. If you haven't done that, you can do it through Raspberry config. We'll enable that. And we're good. Now we have one command that will download all of our software. This will be the one day that this doesn't work either, but install. Imagine some people out there have Zymkeys already. There's quite a few of them out there. Okay, but that's it. And then now it's going to pull down all of our packages and libraries, the daemon software, everything else. It's going to configure the devices for I2C, and all of our API interfaces. We have APIs for Python, for C and C++. We'll play around with those a little bit to set up some tamper detect, and then bring it up. So it does do a reboot in the middle of this. Usually that's to get the I2C bus enabled for sure. Load it back through config.txt as it loads up. It'll load up in a minute, and then we're ready to go.
All right.
So just real quick while we have a second.
Yeah.
If I could ask everybody in our audience, please just take a second to fill out our survey. This helps us learn how to do this show better, how to bring on more awesome partners like Zymbit. So if you just take a few minutes, that'd be great. Save it for later and do it after the show. But that'll help us out. We appreciate it.
All right. Yeah, and we're not going to make it all the way to the end of this demo either,
No.
but we will start because at the end of this demo, there's a question about is Zymkey hot pluggable? Not recommended, but Bob has practiced extensively just to do this trick in front of a live audience.
It wasn't live.
Oh, it wasn't
was
live. Yeah, wouldn't recommend it.
We actually had a customer ask if it was hot removable, so they could boot things up and take the thing away. Right. Which there are ways you could do that, but I wouldn't recommend that either.
No, just don't. Just leave it on there. Especially if it's armed.
Right.
Really don't do that. All right. Yeah, so just at the end of this demo, it's done. I was going to...
it's doing its reboot now, but it's done.
I was going to say something. So at the end of this whole process, it'll start the process of encrypting the file system. So that's what takes a little bit of time. So we're not going to sit around to watch that, but it does get you there all the way. So far we have had some basic Pi configuration to enable I2C.
Yep.
And this is just a plain Pi Bullseye install, and then we ran the Zymbit installation tool, and that has now.
So now we're back up.
That has now concluded, and the device is on. Let me try to swap over to it briefly on here. So now you can see that the LED is not blinking fast anymore.
Right.
So this means that it has found its bits, and so back to the terminal.
Yep. So here's the Zk IFC service is the service that runs that configures this. So we're all up and happy, and that's it for installing a Zymkey.
Well,
so,
and then the file system bit.
Oh yeah. So
started.
The file system right now is not encrypted. What we could do at this point, I could maybe start it, but let me show you a tamper event here on this guy too. So hopefully I have that wired up correctly. So if we just go into, I don't think I have this set up. So we'll show you. I'll just set it up quick. So we'll come in here, and if we actually try and get the perimeter events. Okay, so we had one on 1, or yeah, hopefully I can clear that. Let's see. And let's get them again. Okay, there's 0. So now we're good. And then you want to set it, and there's these are all in the APIs, which this is how easy it is though. So we're the perimeters are 1 and 2 in the outside world, and in software land there's 0 and 1. So we're going to set the first is the events, whether you want to see them or not. We're going to set that to true. The second is self-destruct. We're going to set that to false. With the Zymkey, you actually have to go in here and physically clip that little tab there.
Let me show that over.
Okay.
Yeah. So there's a tab on there.
There's a little tiny tab right here on the side, and that's how you set it into production mode and make all these settings permanent. So on the SCM, it's software controlled, so you can do software bind. You don't need to be there and come out with your snippers and clip it. This one, you actually do have to clip that off, and then it's irreversible. Okay, so we have that set now. And if we get the events, there's none there. And then if hopefully I'm on the right one. I create an event and we've got an event. So you could set that to self-destruct, trigger on that event and blow away your keys. And that's all she wrote. So it also with the battery on it will detect that event, and I could maybe show you that in background here too, or maybe I can show you now. We're running out of time.
We're getting close, but I think we have time for one more event, and then we need to pick up any questions that there are.
Yeah, I was basically going to do the same thing over here and show you that these 4 contact switches works, which you can do whatever your perimeter thing is. We've got that built into our motherboard, so if somebody opens one of our boxes, it'll blow away or take action. So maybe we should kind of wrap it at this. I mean, we've been going a while here. Yeah. Is there anything else let's address questions?
We do have a question. Let me bring it on screen for you.
All right.
A couple of questions. Looks like the encryption runs all in the Pi, correct? Not through the I2C.
Correct. The only thing through the I2C is the locking and unlocking of a Lutz key, so that's protected.
Well, plus the asymmetric keys.
Yeah.
So
I mean, as far as encryption, the whole process is done on the Pi.
Encryption of the file system.
Yes.
Right. Yeah. So the way the file system works is that that's through LUX, and then the Pi uses the passphrase and then does the encryption and decryption. However, asymmetric key operations, such as, for example, computing signature of a hash and so on and so forth, those actually happen inside the HSM. So HSM does key operations basically, but when it comes to bulk data, that's all host side.
Excellent. And another question, I think you touched on this earlier. You made a comment about the paperweight, but is self-destruct irreversible? Is the device unusable at that point?
Correct. It is.
It's irreversible.
Yes. And the reason it is irreversible is because there are many keys that get destroyed, but one set of keys that gets destroyed and never to be found again is the set of keys to the secure element, which is the second layer to the security. So once the keys to that device are gone, they are truly gone. It's never coming back.
With the Pi's case, you can reuse the Pi. The Pi is fine. But
yeah. The Pi itself is fine, right? But the Zymkey is not.
Right. The SCM is extra secure and bound together. So.
Right, and in case of the SCM, right, that's right. In case of the SCM, then the SCM is truly a paperweight together with the associated CM4 because they're epoxied together.
We have just a couple minutes left. These have been some awesome demonstrations today, very informative. Is there anything else you'd like to leave with our audience? How can they reach out to you for more information if they're getting started, if they want additional support? What's the best route to move forward with you?
Yes, so so we have a follow-up QR code. I will plug getting the free Zymkey again. We have a link, so maybe bring up the slide. At the moment, it's on there. Perfect, thank you. Yeah, so we'd love to answer questions and be in touch.
Any upcoming features or products that you'd like to discuss?
All right, yes. So, so in January, we have a beta of our bootware. We did not talk very much about that because there's so many other things to discuss, but that's our secure update infrastructure. A quick plug on that is essentially that once everything is locked down, file systems and boot and everything else, it turns out it's rather hard to keep the device updated because everything's locked up. So what we have is we have a system that updates kernels and everything else with full artifact isolation. So it's really a way to avoid the kernel update anxiety, if you will. And so that's a quick summary of it. And we have a first fully functioning beta of bootware coming out. It's been in OEM use for a little while, and now it's going to become available for general public. I believe there's a sign up under the link for just general sign up, and then we would be happy to inform everyone when that's up and coming. And then the other thing I should mention is we've been showing Rev A's, which are the current shipping units. We have Rev B's of the hardware. Rev B SCMs are shipping, and then we will have a Rev B SEN, which is coming out a little bit later, around February timeframe. So that will have additional HDMI ports and a few cool other features, industrial power inputs as well, a couple other cool things.
Awesome. Sounds like a lot coming down the pipe. It'll be interesting. Maybe we'll be able to talk to you again later in the year and see some of those demonstrations. So, yeah.
Wonderful.
Well, with that, thank you to the audience for hanging out with us today, and thanks for all the interactivity. It was great to have lots of questions and get those answered. Alex Kaay and Bob Guilfoyle, thank you so much for your time and for your demonstrations and for sharing Zymbit with us today. Yvan, thank you as well.
Thank you. Thanks for being here. Thanks for hosting us.
Happy to have you.
We love the work, and hope to see you again.
Sounds good. Thanks, everyone.
Okay.
We'll see you next week.